Okay, so today we're going to be talking about um, functions and arguments and how to make functions be generic enough to be called from most places while still avoiding some problems. So we're going to be focusing on this function called getNewSkill-based-velocity. And we can start with the argument that's passed in by reference, which is the FPS camera. So the first thing is, what is an FPS camera? Well, it's kind of this thick object here. It has a lot of information about like matrices, frustrums, zoom, sensitivity, and it also contains like a mouse object, whatever that is. And somewhere in here, it contains a transform. So yeah, it's inheriting from iCamera, which has a transform. Okay. So let's see how FPS camera is used. So we have compute XZ input direction. It's used there. And we use the transform here. So let's see. And actually, if I see my okay. Here it's taking an FPS camera. You can see it uses that transform. So the only reason we have an FPS camera here is because we use its transform. So this is like, I forgot my keys in your car, and then you give me your car so that I can access the keys. That doesn't make sense, right? Instead, you should either just give me my keys tomorrow, or I can come over and take it out, I guess. But yeah. All we need is the keys, right? We don't need the car. So fundamentally the same thing is happening here. Even though we are passing by reference, so, technically we're not copying any extra data, but this function can modify this object. And so you might say, okay, so put const on that. Sure, but still all like by looking at the signature, you might not know what this function does, right? Because FPS camera is just a container which we use an attribute out of. So it's better to just do that attribute directly, so when people look at the signature, they can infer what it does faster. Okay. So, all in all, we should not be using FPS camera here. That's step one. It's not required. We should just do the transform of the camera. Same goes for the other one. Yeah, same goes for this function. Right. So the cost of making your signatures more specific is that the call sites get dirtier, right? So whenever I call this, I'm gonna have to do FPS, like wherever the real FPS camera is, I have to access it and do like dot transform. So the cost is like moved elsewhere. And so if you want to have the ability to, pass higher level objects, then you should put those in a different place, and they're kind of like converters, right? So it's like, the way I think of it is you have like your HDMI or whatever, port, and you have like different conversion cables or adapters. Like it's like an adapter. So if you have an HDMI port, but you only have a VGA cable, then maybe like there's an adapter you can use to convert before you get to your HDMI port. And those are like specific things that have nothing to do with the internal logic of like an HDMI port. So they should exist like in a separate file. And they could be called like adapters or something like. So like I'm just trying to say that that should be an external clean solution. Anyways, the other thing is it takes in a keyboard mouse update. And here we can see it uses this. What else does it use? This function, which uses this. And these are the only attributes that are ever used. But if we look at the keyboard mouse update, this is a pretty big object. Like, we don't need any of that. We don't need that. We don't need that. We don't need either of that. So there's a lot of extra data that we're not going to be using in here. And this is a specific keyboard mouse update for a specific game. And so I don't want to have to adhere to whatever that is to make it work, to make this movement work in a different game mode or game. So we're going to be exploring how to fix this now. So step one is going to be to grab this repository. And specifically, we use this idea of git submodules to do this. So we're going to go to our client. We're going to go, we're going to figure out where this should exist. I think this is system logic. So we're going to go into system logic. We're going to git submodule add and then paste it in. Okay, so it was already there before, so we're just going to remove that. Try that again. Okay, so I just added the movement here. I gotta make sure everything else is closed just to get a bit of memory back. Movement. Okay, so here it is. And we use something called SBPT, which is subprojects. We're gonna remove the dependency on that and that. All that this allows us to do is to pretty much utilize other subprojects as dependencies. So it avoids having to make things into like C++ libraries. It's like a source code package management system that's local to like my repositories. So the smaller the dependency list is, the more likely someone else can use this easily because they don't have to adhere to or use that code. So this is these are small dependencies and I'm fine with that. So we'll save that. We'll go back here. And then what it will require is it's gonna now depend on the transform. So we'll add that in. So we can run SBPT on here. Get the GLM utils. That's fine. Timer, that's fine. Okay. I'm gonna restart my language server. So now here, I'm gonna say, we're gonna call this transform. Easy fix, 1 underscore. We'll do the same everywhere. Okay. We should be good soon here. I think we've almost removed all of these. Okay, so the only problem now is the keyboard mouse update. And we're gonna tackle this one with a generic adapter approach. So if we, one thing is like, if you list out explicitly what you need from something, so for example here, we explicitly write out the attributes that we need from the keyboard mouse update. If we do that, the one issue we run into is the call sites are big. So you could think of like calling, like, actually we have a sample call. So you can see this call site is big because we have to unpack, pass it in like that. And so the cost of having explicit parameters is that the call sites become big because you have to, because nothing is collected together. So one solution to that is we're going to use something called concepts, which is available in C++20, I think. So I have some notes from beforehand. So we're going to make a, can call this keyboard or a movement input. Like, yeah, that's fine. So all we have to do is we can just use a, let me see how we do this. I'll leave that one as is for now. I'll focus on this one. Okay. I'm just gonna bring this to the header file really quick. And then what we're gonna do here is we're gonna use this template here. So now inside of here, just gonna bring this function in. I forgot about it. So that's good. Here, it's gonna be I think I have to bring this into the header file. So let's do that. So here we do template, movement, flick, T, T, yep. Get new God mode velocity. Okay, so this is much cleaner now. So now this function, this movement class, and its method here, now it only relies on a transform, which is pretty thin. Like this could be thinned out even more and pass only like the vector you need, but I don't mind this. And then the movement input, which is the movement input like, which is just any class that has those 5 attributes. So that allows us to pass in the exact data or any superset of that data, which is great. So this is going to work with the old game, which has the mouse update with a lot of extra stuff in it. And it's also going to work in the current game I'm working on. So this allows us to keep this logic working, and it's pretty much like duck typing, right? So it's like as long as you have, it acts like Python, and that as long as these attributes exist in our booleans, then everything else can still operate normally. And that's all I wanted to share.